We'll continue from our previous program and learn how to use and, or, and not. So if we've got two situations we'd like to check, and they both need to be true. For example, if Wallace cheese is greater than or equal to 27 and Grommet cheese is greater than or equal to 27. That means both have to be true in order for the entire statement to be true. Notice there was a double ampersand in there. We don't use the word and, we have a double ampersand, and that means that both Wallace and Grommet have enough cheese. Right now the double ampersand is blocked. You'll see it in just a moment. Two ampersands back to back mean and. So they've got enough cheese for a decent party if they both have at least 27 pounds of cheese. Otherwise, or else, they don't have enough cheese for a decent party. Going to have to put this on a couple of lines of code, but it will show up on one line in the display. I'll put a little comment here at the end of this to indicate what the purpose of this if block is. Checking to see if they, together, both of them have enough cheese. And they do not. Grommet has 12. That is not greater than or equal to 27. Wallace has 47. So Wallace actually has enough. Grommet does not. So since it's not true for both of them, it doesn't pass the test of being true altogether with and. I'm going to move Grommet cheese to the same place as Wallace cheese so it's easy to change both of them as we test this out. The first thing Java did was check Wallace cheese, then it checked Grommet cheese. Let's give Grommet some more cheese, 52 pounds. We'll keep Wallace at 47. And that means they do both have enough cheese for a decent party. Each one of them is greater than or equal to 27. Both of those expressions are true, so the entire expression is true. Let's reduce Wallace's amount of cheese down to just 3 pounds. Nowhere near enough for a crazy cheese party. Wallace and Grommet do not both have enough cheese for a decent party. Let's take a look at what Java does. Wallace only has 3. The first thing that is checked is Wallace cheese greater than or equal to 27. It's not. The Grommet cheese is never checked. That's called short-circuiting. As soon as one part of an and statement is not true, we're going to drop down into the other parts, in this case an else. So if you're really trying to be a good programmer, you would put the statement most likely to be false early, so the short circuit happens earlier. Next, let's analyze an or situation, where only one of them has to meet the condition to be true. By the way, these examples, I'm just using 2 expressions put together with ands and ors. You can use multiple, of course. To create an or, we're going to use 2 vertical lines. You'll see them just above the enter key. You'll have to press shift. It shares a key with backslash. That's going to be or. So now if Wallace cheese is greater than or equal to 27, or if Grommet cheese is greater than or equal to 27, that means only one of them has to be true. Both of them could be true, but if at least one of them is true, the entire statement is considered to be true. So as a result, we'll know that at least one of them does have enough cheese for a decent party. Else, if neither one of them is greater than 27, then neither one of them has enough. We'll have to find some cheese celebration somewhere else. Once again, a little documentation here at the end of this if block so that I'll remember what this brace ends and what the purpose of this if was. Some if blocks can get pretty large. Again, this is or. If either one of them has 27, that will make the whole thing true. And at least one of them does have enough cheese for a decent party. If we go up, we'll see that it's Grommet. Wallace has 3, Grommet has 52. Wallace cheese is checked first, that part is false, so Grommet cheese must be checked, that part is true. That's all we need is one true part of an or. That makes the entire thing true. If we give Grommet 73 pounds of cheese and Grommet just 2, let's see what happens. At least one of them still has enough cheese for a decent party. The short circuit thing happens again here in this or. Because Wallace has 73, this first part of the or is true. The second part will never get checked. As soon as one part of an or statement is true, Java will short circuit and go into that true part. In this case, the statement that we have enough cheese, at least one of them has enough cheese for a decent party. So if you really want to be a great programmer, you would put the part most likely to be true first, or early in the or. Next, let's check out how an exclamation mark can be used for not. We saw that earlier with not equals. First, I'm going to make a Boolean variable, can play guitar, and I'll set it equal to false. Then I'll create an if statement. If not can play guitar. So if not can play guitar is true, which means it's false. Think about that. If not can play guitar is true, that's false. So, if it is true that it is false, then you are not able to play the guitar. Otherwise, you can play the guitar. Again, think of that exclamation mark as not. So, if not can play guitar. And we do have can play guitar currently as false. Let's test it out. And you are not able to play the guitar. It is false that you can play the guitar, so it is true that it is false. Again, think about that. Not can play guitar is true because it is false. It might take a little bit to wrap your mind around that, but it's the opposite of being true. It's a way to make false the truth. Sorry if that's confusing you, but that's what we're doing here. Sometimes it makes it easier to read. For example, if we have this Boolean variable done and we set it equal to true, and we use the exclamation mark, you can kind of read it, if not done. Well, that's the way people talk sometimes. So if not done is true, you're not done, which means the variable done would be false. If done equals false, you're not done. Otherwise, you must be done. The variable done would be true. We'll see how this works in just a moment. Remember, we have currently set the variable done to equal true. Here we go. And you are done. Done is true, so it is false that you are not done, so it must be true that you are done. If I change can play guitar to true and change done to false, see if you get the answers you're expecting. There you go. You can play the guitar because if not can play guitar, well, you can play the guitar. It's true, so that'll drop to the else. And if not done, Well, that is true. You are not done because false is the opposite of done. You'll notice we didn't use any double equal signs in those situations. We can also do that here in this Boolean situation. If popsicle frozen, I don't have to say double equals true. If I leave that out, Java's going to assume we're checking to see if popsicle frozen is true. If it is true, you can go ahead and eat your popsicle ice pop. Technically, that is the phrasing we're supposed to use. Popsicle is a trademark phrase. You can go to the Popsicle website and read about it. Otherwise, if your popsicle is not frozen, you're going to have to drink it. But again, notice we didn't use popsicle frozen double equals true. If we just say if popsicle frozen, Java assumes we want to see if that is true. Let's try it out, knowing that we have set it to true. And you may eat your popsicle ice pop. If we change it to false, now you'll have to drink it. It's a not so ice pop.